Good morning, class, and welcome to Mindustry Academy. My name is Mr. Light, but you may call me Hikari. Today's lesson we will be focusing on the methods by which you can move items. First off, the conveyor is the simplest movement block, and is the cheapest way to move items. It accepts inputs from all angles and outputs to one direction. It is the slowest of the conveyor block types at just over 4 items per second. The simplest way to distribute items is with a router. It divides up the output of 1 to 3 inputs and outputs to 1 to 3 different directions. They contain storage for one item and are the cheapest method which you can use to send items along different conveyor lines. Routers treat each other's inputs as outputs as well and vice versa, meaning that there will frequently be latency between two adjacent routers moving items along the chain. This problem becomes significantly worse if there are more routers. Please do not do this. Junctions enable items from perpendicular supply lines to cross without mixing. A common use case for junctions is ensuring the contents of a supply line remain untouched while running parallel and adjacent to another supply line with routers and other distribution blocks. Basically, junctions can be used to make sure routers don't send items to supply lines you don't want them to. On another note, junctions adapt to the speed of incoming items, meaning they do not limit bridges to 4.2 items per second, when both the bridge and junction are in use. This is more advanced knowledge, but when junctions experience a backup, items will remain in the junction despite not technically being in inventory for them. You cannot check this by normal means, but if you have a schematic and your inputs get mixed up somehow and the machine you placed is not working, replacing junctions can be a fix due to this mechanic. Distributors are larger versions of routers with 4 more effective spaces for either distribution or consolidation. They share all the drawbacks and upsides of routers. While these are mostly useless, they do serve a purpose in early game defenses and schematics. Otherwise, there are just better tools out there which accomplish the same thing distributors do, but more effectively. Shown here is an example of how bridges can be effectively used. They move items at a rate of 11 per second, which is as fast as the next tier of conveyor without the required titanium to build it. If you are in the campaign without titanium, these can be substituted for their throughput capacity. Each point on the bridge holds 10 items, and can travel a maximum of 4 blocks before needing a connecting point to proceed. This was discussed before, but it's relevant now. Items cannot enter the underside of a bridge entrance. Items likewise cannot exit backwards from the bridge exit. A bridge exit can be shared by multiple bridge entrances. Also note, it's easy to forget that the output of a bridge can mess with other existing supply lines if they are adjacent. Essentially, it's like a router, but it doesn't send items in one direction, but sends it in the other 3. Bridge weaving is a little-known practice among those more experienced in the game, because of its high throughput potential. It is, however, very hard to work with without extra visuals which are currently shown on screen. Use this concept sparingly and advocate for using bridges without weaving them like this if possible, if nothing else for your own sanity. Gates are very effective distribution methods. They instantaneously move items from the input to the output. They don't contain an inventory, and are just generally better than the router and distributor in most cases, hands down. Overflow prioritizes sending items forward relative to the input, while underflow will do the opposite. Only two can be put along a supply chain adjacent, and their use in the example is what it looks like when they are effectively at their limit. You'll also notice that we have more than two adjacent here, but because of where it's coming from the input, it all still works. The input being this bridge exit. So, for instance, if there was a gate here, copper would not be sent down this line. Sorters have the same throughput limits and properties of gates, but restrict items from going in a specific direction. Regular sorters which have not been set will only move items from the input to the side. When set, items along that supply chain with the matching item on the sorter will proceed forward while the rest will be moved to the side. The opposite is true of inverted sorters. These blocks see the most use in mixed belts late game, and as well as many compact schematics. This concludes the lesson, Basic Logistics and Distribution Methods. Bear in mind, this material is not made so that you can rub it in your friends' faces about how inefficiently they're playing. If you relay anything you've learned from this video to someone else, please be tactful about it. They may not have thought about using a block in a more effective way before. And on that note, this class is dismissed, and I will see you next session. Goodbye.